The broadcast is now starting. All attendees are in listen-only mode.
Hello and welcome to our webinar on Express Marine. I'm Bruce Hayes, a naval architect with the Advanced Marine Technology Center of DRS Technologies in the U.S. We're the developers of the Orca 3D naval architecture plugin for Rhino, and we're the North American distributor of Express Marine and Shipweight. The agenda today will begin with some brief introductions, followed by an overview of Express Marine. Then we'll present a live demonstration, discuss the pricing options, and finally have some questions and answers depending on time. We expect the webinar to last about 45 minutes. For those of you who may not be familiar with the GoToWebinar interface, you can click on the orange arrow on the control to minimize the control so you can see more of your screen. If you have questions during the webinar for our panelists, you can type those into the question box, and if we have time at the end of the presentation, we'll try to address them. Otherwise, we'll assemble a list of questions and answers and distribute them in a follow-up email to everyone. We're recording today's webinar, and we will include a link to the recording in the same email. The first of our panelists is Runar Olsen of BAS Engineering in Norway. Many of you know Runar as one of the developers of the Shipweight engineering software. Next is Yulu Prepalita. Yulu has a background in naval architecture and programming and worked for several years for Rolls-Royce Marine as a structural engineer and in hydrodynamics before starting Express Marine. Now I'll turn things over to Runar for an overview of the software, and then Yulu will follow up with the live demonstration. So Runar, let me make you the presenter.
Thank you, Bruce. I will continue this webinar with few slides just explaining very briefly what Express Marine is. So Express Marine is algorithmic marine structure modeling plugin for Rhino. And what does that mean? The main objective of the tool is to get from a 3D hull surface combined with a 2D design drawing of a GA typically, to go from that as a starting point to get a 3D structure modeling in no time using Express Marine, and to get from the surface and the 2D drawings to the 3D structure faster than any other tool available on the market today. So how do we do this with Express Marine? Well, we do it through using window that the structure and models that are able to structure and give you a parametric modeling of the 3D marine structure by using a 3-view. In that 3-view, your vessel is organized in a hierarchy where you have the complete vessel at the top. It's then divided into the various decks. Each deck is divided into girders, bulkheads, webs, and so forth, which again are divided into their substructures. And within the 3-view, in each of these nodes, this is where we design or create the actual objects. And we do it not by drawing in a typical old-fashioned way in the 3D tool, but by using references and limits, and create it by saying that, okay, my new object will be inside the hull. It will be referenced to stop at this deck, and it will be having these type of stiffeners and these type of openings, and we give in codes to how stiffeners and openings are distributed and created, and we set X locations. So we have automatic creation of structure object based upon limits and references. Another thing we do is that we have automatic repetitive tasks through mathematical algorithms. This means that if you are doing a repetitive task, in example creating many floors within a certain span of frames, you just define the creation like you would do with one floor by specifying the limits, the type of stiffeners and so forth, and then you say that this should be repeated, for example, for every third floor, starting at frame 40, ending at frame 118, and then it will use these parametrics on every one of those frames, creating a floor automatically for every one of those frames. Another main point is the associative topology, which makes it very easy to do the design follow-up. This means since all objects are referenced to each other, when you change the position or size of an object, any object that's been referenced to this follows. If you widen the hull, all objects that's attached to the hull automatically widens along with it. And further, there's a link between the 3D elements and the 2D drawings, which means that if you change the position of a bulkhead in the 2D drawing, the bulkhead that was created from in the 3D model will also follow, because the 2D elements are linked to the 3D elements. And the structured tree view also gives us, in addition to give a hierarchy overview of the vessel, it also naturally gives you a workflow and gives you a step-by-step driven process and guides you through the whole modeling. So you will start out by defining the floors, the girders, the webs, and then add on with the bulkheads, and finally the superstructure. So you also get a very structured workflow with the tool. And the results is a quicker than ever way of making a 3D model of the structure, which is suitable for meshing for FEM as a preprocessor for detailed design, and last but not least, gives you a very good weight and central gravity information for the structure, and which in the next phase can be easily exported to ship weight for adding equipment and doing further weight and CG calculations for the total vessel. So with that, I will end my slide overview.
Okay,
and,
thank you, Runar. Yeah, I will make you the presenter, and he can move on to the live demonstration.
Hello everybody, this is Yulu from Express Marine. Thank you so much for joining us today on our webinar. I will demonstrate hands-on how to apply Express Marine to ship design. We will use the version 1.2 of Express Marine, which we are happy to announce today. It will be available for you to download later today. We will demonstrate to a project of a 150 meters cruise ship. We will begin by opening a new Rhino project, and to initiate Express Marine, we simply need to type Express Marine create project, press enter, and you will see that the main parameters window will pop up. So I will name this project Demo Cruise Ship. I will select the ship type to be cruise ship and fill in the rest of the main dimensions, then press apply, and you will see that the Express Marine window will open. And as Runar said, you will see that on the left you have the tree view, and on the right side you have the control panel where you set in the parameters. Each node in each row in the tree, we call it a node, and the top node, that's the project node. You will see that on the right it contains few tabs. The first tab contains main parameters again, so that you can change them at any time. you also have the possibility to import the general arrangement drawing here, and you can also see the result for the entire ship weight and center of gravity. Next, there's the framing system tab, where you can define your grid. You need to press apply to confirm it. Then you have the catalogs, where you can define your custom materials. The first step would be to import the general arrangement. So we're going back to main parameters window, and let's import the GA by pressing browse. And now you can pick a general arrangement drawing which is in a file format supported by Rhino. Press open to bring it in, and you will see that our GA will fall right into these selection rectangles that Express Marine has generated, but you will have to do the same to get to the same layout when you will import your own general arrangement. So you will need to drag in into each selection box the appropriate section. Okay, so a good idea is to always work on a clean GA. So try to hide all unnecessary objects like equipment or hatches and so on. We have a small video about this on our website, and you can find more information, more detailed information in the user manual. Next, let's import the hull surface. So we go in Shell and we check that the symmetry is active. Yes, so then we go to Shell PS node, and we need to import here just the Shell PS part, the port side half of the hull surface. So press browse and then pick the hull surface, bring it into the model, and you will see it has been brought here, and it's grayed out, which means that it's locked. You cannot modify it in this stage because we bring it just to be seen and visually inspected. And if it is the correct surface, then we can continue with the definition. And we notice that this hull is already trimmed to the correct shape, so we don't need to use any limits for that. So we can clean this limit table by pressing the minus button. And now we can simply press apply to transform it into an Express Marine object. And because it was symmetric, you see automatically we have obtained also the starboard half. And as you notice, the transom is missing. So this is a good opportunity to show you how you can customize your tree. And for this, we will add a custom group into the shell by right-clicking onto the shell node, add custom group, and then you can rename this group. Let's call it Shell Custom Surfaces. And inside this custom group, we can add an X object. What an X object means? It means that the orientation or the normal of this object is in X direction, like the transom is. So we can rename this as well to transom. And now we are ready to import the parent surface for this object. What a parent surface is, all objects are created onto surfaces which ideally should be slightly larger than the actual element we want to obtain, because we want to have a larger surface from which we want to cut that specific object. So if you import this parent surface, and then we have it prepared, received from the designers, press open, and you will see it has been brought into the model. And now we just need to cut it to the correct shape. For this, we will need to add the Y limits. So that will be between the shell starboard and shell port side. And on the Z limit, it should be less than 21.1, which is the highest point onto the shell. If we press apply, then we obtain the object transom. As you can see, in the lower part of of the control panel, you can see already the results for this object, for the transom. Do not forget to save from time to time. You simply need to use the Rhino command to save it. We can cancel this one. Okay, so next we can now start generating some decks. So I will go in deck 3, for example, because I want to show you a flat deck. And this is a good occasion to show you how else we can generate any object. You will see we have several modeling methods. The first one being on a flat plane at a constant coordinate. So for a deck, because decks are usually flat, they are at the constant z. So deck 3 is at 9 meters. And then we can give a thickness if you want and a material, and then we need to input some limits. For example, we know that this limit is at y larger than shell starboard and less than shell port side, and then x is larger than transom. And now we can apply, and as you can see, we already have the result for that deck. Now I can show you the second way to generate a deck, or actually any object, when we pick a trace. That's how we call the curves representing structural objects from the GA. So we would go in deck 2 and pick the second modeling method, pick on GA, press on pick on GA button, and then we pick from the profile the curve representing the deck 2. And as you can see, this is a knuckle curve, so this has some steps in it. So it will be a good example. And now, as you can see, the trace input field has been filled in with a trace name. We need to give some limits to this, and because the limits are the same as for deck 3, we can just go in deck 3 and copy all the limits, and we will paste them in deck 2. So now we can apply. Just a second. Yeah, it was a small space after. So if we apply, then we have generated the second deck. And now that we have 2 decks, we can generate some bulkheads in between them. So we go on bulkheads from tier 3, and we can start picking them straight from the GA. You will see that the trace box is empty, and now if we pick the button, if we press the button pick traces, then we can start picking traces from deck 2. So we go in the box, selection box that's called deck 2, and then we can start selecting some bulkheads. So then we do that for all the bulkheads all the way, and then we can simply press enter when we're ready. And you now see that the trace box has been populated with objects, and each trace has been automatically recognized if it's a longitudinal or transverse trace, and got the appropriate name. So now we can give a material and the thickness, and then we can go back to limits and maybe input some limits. But usually for the bulkheads, because we know we are in deck 3, the program automatically suggests to use as the Z limits between deck 2 and deck 3. So you can leave them as they are. So you can press apply. And if you see there, all the bulkheads are being generated in between the decks. And now, if you notice, some of the bulkheads go outside the shell. So what would mean? It means that we need to also fill in the shell SB and shell PS limits at Y. So we just apply again. So now, as you can see, the shape of the bulkheads is correct. They stop at the shell. And as you can see, we have the results for the weight and for the center of gravity. And also the bulkheads, they are split in two groups. One will be for longitudinal bulkheads and one for the transverse bulkhead. And if you need to modify any of the bulkheads, you simply go into any node and you can apply separate settings. And as you saw in Runar's presentation, if you would click on one of the bulkheads into the GA, then that bulkhead will also be highlighted in 3D, and you will also see it in the tree. So now you can update it or modify it as you require. Maybe I can now show you how to create some openings. And let's say in deck 3 we can start to generate some openings. And to do that, you see in the cutouts and opening box, you have a plus button. This, if you press it, you will see that a menu opens where you can choose one of the types of the openings. And so we have regular, series of regular of repetitive identical openings, or we can have openings which height varies depending on the contour of the element, or we can have openings that follow the contour of the entire element. So we call this a parametric opening, parametric offset, or you can pick from the GA a closed curve that represents an opening, and that closed curve will be punched into the object that you want to create. So for this deck, let's pick the first choice. And here we give a name. Let's call it OP1. And let's say we started from frame 50 up to frame 70, and with a spacing between them of 1 frame. And then the Y coordinate of the center of the openings, it means how far they are from the center line, and let's say 3 meters. And from the opening list, we can choose one opening. Let's choose the manhole. And you see we just proposed initially one value, but you are free to modify that. Just type in the dimensions that you need, like 650, let's say, times 400. And we can apply, or we can confirm first, and then if you press apply, you will see the series of openings that we have created. And if you want to modify this somehow, you just press this gear button, and then, for example, let's add some exceptions. And let's say that at frame 55 and frame 56 we don't want to add an opening, and maybe we can add some more outside the initial interval. And let's say we add a mini series. For that we need to use brackets and then say again the repetition interval, and that's, let's say, frame 1 from frame 80 to frame 90. So let's confirm this, and if we apply again, then we get some more, and the exceptions that we didn't want to obtain. And maybe I can show you now how to define some stiffeners. Again, in the stiffener box, you will see a plus button, and we press that. So now, again, we can make series of stiffeners depending on the element type. So let's choose to make some longitudinals, and we pick the button in the corner, yes. So let's call it longs, longitudinals, and the Y start to be frame minus 13, let's say, up to frame 13, every 1 frame, and let's choose a profile. And because we don't want to choose any border, then they will go all the way on the length of this object. So if we confirm and apply, this is the result. So we will get stiffeners all the way. And maybe I can show you how to add some borders. You go again on edit button, And let's say at the aft border, we fill in frame 30. But you could have also click that arrow down and choose a surface that may make sense for your project as the border. But you can also use values. And let's say up to frame 110. And also, if you want, from that border, you can use an offset as well. Let's say 300 millimeters. And maybe an exception as well. Let's say not make it at frame 0. And then we can confirm and apply. So now they are much shorter, and also one of them is missing. The one that we wanted, the exception, is not being created. Okay, so maybe now I can switch to a more advanced model, and I can show you how we can build up a full model. So I'll close this one, and I'll open the complete project for this ship. So it may take up to 30 seconds to load because it's a very large and very complex project. Yes, so this project is complete, but most of the elements are hidden so that I can show you step by step how this has been created. What you see now is just the double bottom structure. And let's take, for example, those magenta objects. They are the bilge plates. And as you can see, in the aft part, I have intentionally skipped, not created some of them, so that I can demonstrate to you now how to create them. And I have pre-filled one group. So I'll make them from -11 to -7, and I'll skip also the frame -8 because we already have a floor there. And the borders, they're from the longitudinal girder all the way to the shell. And on the upper border, I have used the deck to plane. And also to create that central opening, I have used the parametric offset using the same borders as those limiting the objects. So we can confirm this, and when we apply, because this element has symmetric activated, they will be created on both sides. So you see how they're being brought into the model one by one. Now maybe I can show you how to create some floors. If we look into the model under the engine room, half of the floors under the engine room are missing. So let's create them now. I have pre-filled one group. So I'll make them from 54 to 60 every 2. And for this, if you notice the other floors, they have a series of openings that follow the contour of the shell, and I can show you the definition of it. So if you go on Edit into Cutouts and Openings, this is the definition of it. So I have used as the side borders the shell surfaces, and on the upper border I have used the deck surface. That's the tank top, and with an offset from that from those borders. For example, I wanted 200 millimeters from the tank top and 300 millimeters from the shell. So if we confirm, and we're pressing apply, or maybe I can show you first some stiffeners as well, because this element has a flat band at every frame space. So that is the definition of those frame spacings. And as you can see here, I have used as borders the shell and the deck one, that's the tank top, and with the small space so that the stiffeners from the tank top and from the shell will not collide with these flat bands. Then we can confirm this, and if we apply, This may take a bit longer because it's quite heavy definition. It needs first to cut the object, and then it will identify the borders and offset the borders, then create all those openings and then all the stiffeners. So it may take about 15 seconds per element. But the regular elements, they're usually a bit faster. Still loading. Sometimes it happens for a heavy definition to be brought into the model all at once. So you see that gap is now filled with floors. Okay, maybe I can show you one more example. You see those light blue elements, they're the docking plates. And just before them, you see there's an area that they were not defined. So I have specifically left that blank to demonstrate you. We will need to go into docking plates and in the demo subgroup. I want to make at every frame from 40 to 52, except for the positions where we already have a floor. And then I border them from the shell all the way to the tank top. And to make that shape for the opening, I have simply placed a regular rectangular opening with round corners and place the center of that on the vertical edge of that. I can show you the definition of it. So here is just a simple series of openings. We can confirm this. So now we can apply to see the result. And they are being brought into the model one by one. And as you can see, where there was a floor, it has skipped that position. Okay. If I zoom out a bit, you will see that this deck, the tank top, is actually split in two surfaces. It's stepped. So to achieve that, we have the possibility to right-click on deck 1, and you simply add a new deck plane. So this way I can split that into two planes, and then you can define the second one. And also, if you look at the definition of the stiffeners, this is a bit more complex. And what I did, I just add more groups one by one until I obtained the correct stiffener definition. Now maybe I can open the double side to show you the inner shell and the webs. So I will turn the visibility on. And this inner hull surface, I have simply imported that. So I have pre-made it before and imported the same way as I imported the transom. And the webs, they were created in the same manner as floors. And I have used two parametric offset openings to create those cutouts in the webs. And maybe I can show you also some bulkheads, some finished bulkheads, how they look. I will, for that, I can simply turn on the visibility for tier 2. So here it is, that knuckled surface we made previously. It's just this one has more complex stiffener definition. And if I turn the deck surface off, we can see the bulkheads underneath it. And as you can see, it's identical to the traces in the general arrangement. So let me now just open all the way up all the all the tiers, turn the visibility of all tiers to show you how the complete model looks like. So now you see some of the objects are a bit more complex. They are simply imported parent surfaces received from the designers. A good example is this casing and also the wheelhouse. I have simply received them from the designers and imported them here. And if you want, you can just divide them into more clear objects, and then you can go more into details and place stiffeners and cutouts on them. I would say that this model is complete in phase one. We usually like to model this type of projects in several phases, and we call the phase one the weight assessment, where we make a general model to be mostly used for the weight evaluation and also for the overall, to get an overall idea of the surface. And now I finished opening everything, and from the shell starboard I will turn off the plates so that we can see better inside. So this is the complete model. And now if we would go in the project node, we can see the value of the weight and the center of gravity for the entire ship. And what I like to use is a clipping plane to be able to check the internal structure. So we can do this and create this clipping plane. And now all I'll have to do is to drag this plane. So then we can see how the internal structure looks like. Yes, so this is in big lines how you can create a complete project. If you want to see this project and use it as your reference, you are welcome to ask us to send it to you, but you will have to download and install the Express Marine version 1.2 to be able to open it. So I think now we have time for some questions. So I'll give it back to Bruce. Thank you so much.
Thank you. Let's let Runar talk a little bit about the pricing. So I'll go back to making Runar the presenter here. And while we're waiting for that, can you talk a little bit about how people can download an evaluation version of Express Marine?
Yes, thank you, Bruce.
Maybe Runar can comment on it as well, looking at the website here.
Sure. So as you can see, that is our website. They can simply go on expressmarine3d.com and go to buy, to download, and there is where they will find the version, the trial version. For the moment, the version that is on the website is the 1.1, but soon after this webinar, we will upload the 1.2 version, so you will be able to download it and try it. We will also increase the trial period to 30 days because we noticed it takes a bit longer for people to try it.
Okay, and all that's required is Rhino 5, and I assume the latest service release?
Yes, Express Marine works with Rhino 5, so you will need to have Rhino 5 installed on your computer prior to downloading Express Marine.
Okay, very good. Thank you.
Thank you. Thank you, Bruce.
Runar,
Right.
would you like to talk about the pricing model?
Yes, certainly. So you can find pricing and pricing model on the expressmarine3d.com website if you go to the buy section of the website. And basically, the first thing you need to ask yourself is whether you want to go for the Pro version or the small craft version. And the difference is that the small craft version works for vessels up to 24 meters in length and up to 3 decks. If you go beyond that, you will need a Pro version. But besides that, they are identical in the functionality. The next thing you need to ask yourself is whether you want a standalone version or a network version. Network version will work on any computer where you install the software, but only it's limited to work only the license determines how many users can work on it at the same time. So if you have one network license, you can have one simultaneous users. If you have 3 network licenses, you can have 3 simultaneous users, but the software can be installed on any client machine, a number of client machines in the organization. The alternative to a network version is the standalone version. The standalone version will only work on the computer at where it is installed. When you know these two things, you have the options of either renting the software or buying a perpetual license. If you rent the software, it's a yearly rental, and it will include the license, it includes maintenance and support, and it includes any upgrades that may come to the software within the time you rent it. If you buy a perpetual license, you have bought the license to the particular version that you've downloaded and at the time you buy it, but you also have the option to go for a support and maintenance agreement in addition to on top of the perpetual, which is then a yearly fee to cover support, maintenance, and upgrades. So these are the options you have. In addition to the small craft and Pro version, we have also an educational version, either as a lab kit for university or as a student. Right now we have early bird offers available at 20% discounts, and the prices you can find on the website, in addition to, of course, the information that I just gave you.
Okay, thank you for that, Runar. We're running close to the end of our time here, but I think we have some good questions that we can try to address quickly. So the first is, and maybe you might want to answer these, can you export the model to detailed design software?
Yes, well, yes, definitely possible. For this, the users will need to use all the functionalities that Rhino provides, so they can export in any file format that Rhino supports, and then they will have to import that into their own detailed engineering softwares. For the moment, this is a manual process, but we plan to develop some functionalities in the future that will allow an export of a rich model and also a direct link to particular detail engineering softwares.
Okay. The next question is, how long did it take to actually model the demo ship that you use today?
This is it was a very complex project, so it took about 25 hours to complete, but the time can vary a lot depending on a lot of factors, mostly the complexity of the vessel, or what are the available information, or how proficient the users are in Rhino. So let's say for a regular merchant ship, it could take from 10 hours to 100 hours. And from there, you can take it as long as possible, depending on how many details you want to add into your model.
Okay. Next is, what is the difference between Express Marine and Orca 3D? I guess I can take that. So Orca 3D is a naval architecture plugin for hull design, hydrostatics and intact stability, and resistance estimation. So whereas Express Marine, as we've seen, is a structural design plugin. So they're not overlapping in terms of their capabilities, and we are planning to, in the future, have an interface between the two. Of course, they're both Rhino plugins, and the hull surface that's developed in Orca 3D, or any surfaces that are developed, can be used as input to the Express Marine modeling process that we saw today. How could the Express Marine model be used for finite element analysis?
Maybe I can answer this. Well, for the moment, this would again be a manual process, so you will need to export your model, for example, in IGES format, and then bring it into your mesher, into the tool that creates the mesh for your FEM analysis, and then generate the mesh there and use it further for FEM. But we also plan to create a FEM a meshing module in the future, so that you will be able to export your mesh, the rich mesh, straight into your FEM tool and start your analysis right away.
Okay. The next question is about drawings. Is it possible to extract drawings from the model?
Yes, absolutely. And again, you would need to use Rhino functionalities to do that. For example, you could use a project curve to surface, or make 2D drawings, or the function contour. And this way you will generate sections, and then you can extract them as DXF or whatever you need, and take it further in AutoCAD and continue create production drawings or class drawings. However, again, we plan to implement our own drawing module in the future. So we will simplify that work a lot.
Okay. This next one looks like maybe it's for Runar. Can the structure be exported to ship weight?
Yes, certainly. Express Marine has an export function that can export all the information about weight and center of gravity for all of the structure objects. It's exported into a CSV file, and this CSV file can be imported easily into ship weight.
Okay. And I think the last one we have time for, can Express Marine be used for smaller craft like sailboats?
Maybe I could take this. Yes, absolutely. There is literally no limitation for the types of the ships that can be modeled. We could use it for very large commercial ships, or for very small crafts like boats, sailboats, or workboats. Actually, it's so versatile. It can be used for oil rings, for pontoons, and why not even for non-marine applications. Actually, anywhere you think that you may use a parametric model, Express Marine can be used.
Okay. Thank you. So as I said, we're running over our time, so we probably should stop there. If you have any other questions, please feel free to send them to support@expressmarine3d.com, And visit our website, expressmarine3d.com, where you can find some more information, some videos, and as you described earlier, you'll be able to download an evaluation copy there. We will be sending an email follow-up to this, which will have a summary of the questions and answers, as well as a link to the recording. So Runar and Yulu, thank you very much, and thank you very much to all of you attendees for sharing this with us today.
Thank you as well. Bye-bye.
Bye-bye.
Thank you.